Okay, this lesson is going to be about solving quadratic word problems. This is a really big topic, not only in Algebra 1, but also in Algebra 2. It comes back in future classes after that as well. What I love about quadratic word problems is there's really only a certain number of things that they can ask. So as long as you understand what's happening with the parabola, what the graph would look like, and you really pay attention to what each piece, axis of symmetry, the y value of the vertex, x-axis, y-axis, if you're really analyzing what all of those different pieces and characteristics mean in the context of that problem, then it's really not incredibly challenging. So before we jump into a couple of examples, the first thing I want to do is walk you through some helpful tips for working on quadratic word problems. So the first tip is just draw a picture, label everything, label your x-axis, label your y-axis. Are we talking about time? Are we talking about height? Is it in seconds or minutes or feet or yards or meters? But label. When I say draw a picture, I don't mean that it has to be a perfectly in context picture with birds or rockets, but actually drawing your axis and sketching the shape of the graph. The next part, identify what part of your picture the question is asking about. Sometimes a question will only be asking for time, which is often the axis of symmetry value, or maybe it's asking for the maximum height, which is the maximum value, the y value of the vertex. So make sure you know what the question is asking about. A lot of times when students are working through these problems, they just go through the process of what you always do with a quadratic, and they start by finding the axis of symmetry, they plug it in to find the vertex, and then they get to the question, they don't actually know which part of the question, which part of the work they did answers the question that they're looking for. So identify which part, which characteristic is going to answer the question that's being asked, perform the necessary calculations, and then write your answer. Make sure that you're answering the question that is being asked, meaning if it's asking at what time, is it a certain height, you should be answering using units of height. So what we're going to do right now is we're going to look at a couple of examples. Example 1, a stormtrooper is kicking an Ewok off the ground. The path of the Ewok is represented by the equation h of t equals negative t to the second power plus 8t, where t is in seconds and h is in meters. So I'm going to go ahead and underline some of the important information in this problem. Obviously, I'm going to need the function. It's important for me to know that t is in seconds and h is in meters. So I just like to start by underlining all of those things. Part A says graph the equation over the interval from 0 to 8 on the accompanying grid. Now, I tried to do this a couple of times on this little tiny grid, and it did not work on my iPad, so I'm going to actually go back, write my function over here, and do all the work over here so it's not smashed and it's easier for you to read. Okay, here's my function. Now, if I'm going to graph it, just like we spent a lot of the time last week doing, we first need to find the axis of symmetry, and we need to plug that in to find the vertex. But when it says draw a picture and label everything, the very first thing I'm going to do is just sketch what is happening so that I get an idea of what's going on. I'll go back and identify the ordered pairs over the domain, which it asked us to graph from 0 to 8. But the first thing I notice is that my a value is negative 1, which means my parabola is going to be opening down. I also notice if I plug in 0, t, h of t, if I plug in 0, I get 0. So my parabola is opening down and it hits the x-axis at 0, 0. It's going to look something like this. When you're sketching the shapes of these graphs, they should look rounded. This is not a great sketch because computer technology is not my favorite, but it should not look like straight lines. It should not look like a V or an upside down V. That would be an absolute value graph. So what I want to do now is label my axis. The x-axis is talking about time, and we said our units for time were in seconds. And the y-axis is the height, which it said was in meters. This right now really helps me analyze what this is talking about. I have a rocket, or no, I have an Ewok that is being kicked and traveling along this parabolic arc. So those arrows are just showing you the way that it's traveling. It's getting kicked up into the air. At some point it gets to the highest place it's going to reach, and then it starts coming back down. So having that visual understanding, so this point right here, whatever that point is, that's going to be our vertex, which means that the x value of our vertex, which x is time, is going to be the time of the max height. And the y value of our vertex would be the maximum height. We'll come back to that, but I just want you, when you're sketching that picture, to really think through what each part means. So let's calculate our axis of symmetry. In this case, it's actually not going to be x equals the opposite of b over 2a. It's going to be t equals, because our function is in terms of t equals the opposite of b, which is negative 8, since b is 8. The opposite of that would be negative 8, over 2 times a, and a is negative 1. So this is going to give us 4. Negative 8 over negative 2 is going to give us the equation t equals 4. So remember, when we're making our table, that means that 4 is going to be in the middle of our table, and this is not all going to fit, but we're going to be okay. Okay, I think that is going to be easier for you to read. So we found that our axis of symmetry is at the value t equals 4. Now, if we plug 4 into this equation, the opposite of 4 squared plus 8 times 4, 4 squared is 16, then we make it negative. Order of operations, remember that that negative happens after you square the value. So 4 squared is 16, then we make it negative. 8 times 4 is 32. Negative 16 plus 32 is going to be 16. So this point right here is the vertex of our parabola. Most of the time when we're working on word problems, that vertex is going to answer pretty much any of the questions that are being asked. It's possible that it won't, depending on the context, but a lot of the questions are going to come straight 4 is the answer or 16 is the answer. Now remember that parabolas are symmetric, so once I know that this is the point in the middle, I actually have gained some information about the rest of my table. If 0 is 4 below the vertex, then I can go 4 above the vertex and figure out that at 8, 0, that is actually going to be my other x-intercept, because those points are symmetric. So as long as I know one on either the left or the right, I can reflect it over to know the other. That means that I can either plug in 1 or I can plug in 7 into our function, and those values are going to be the same. Personally, 1 is a lot smaller than 7, so I would rather plug in 1. If I plug in 1, let's make a little bit of space here. If I plug in 1, remember that negative sign happens last. I get the opposite of 1 squared plus 8 times 1, which is negative 1 plus 8, which is 7. That means that 7 is also at 7. When I plug in 2, so I could either plug in 2 or I could plug in 6. I would rather plug in 2, so the opposite of 2 squared plus 8 times 2 is going to be 16 minus 4, which is 8. 16 minus 4 is not 8. 16 minus 4, which is 12. And then if I plug in 3, I'm just going to do this quickly, we're going to get 15. So here's the table. If I was actually graphing this on a coordinate plane, I would graph each ordered pair with precision. That's really hard to do on the iPad. If you're doing this, if you were able to print out the notes, make those points precise on your graph. That's going to help you out a lot. So this was part A. I'm going to flip back to this as we go through the problem, but let's look at part B. Part B says, what is the y-intercept and what does it represent in this problem? So let's look at our graph. The y-intercept is what happens when x is equal to 0. Well, when x is equal to 0, the value of the function is 0. So the y-intercept is when x equals 0, and when x equals 0, or I guess I should say when t equals 0. When t equals 0, the function is at 0. 0 feet. Nope, not feet. 0 meters. What this means is the Ewok starts on the ground at 0 meters. So he's flat on the ground before the stormtrooper kicks him. Part C says, what is the axis of symmetry? We got that on the page before. That was t equals 4. And what does it represent? So remember, we're talking about a parabola. At 4 seconds, the rocket is at its highest point. So 4 seconds. At 4 seconds, the rocket is at its maximum height. Now, 4 isn't the maximum height. 4 is the time that that height occurs. What is the y value of the vertex, which was 16? And what does that represent? 16 meters is the maximum height. Part E, how long is the Ewok in the air? So the Ewok is in the air from when this starts all the way traveling over until it hits the ground again. This was at 0 and this was at 8, which means it was in the air for 8 seconds. And we know this because these are the x-intercepts. Or because at 8 seconds, it hits the ground again. Part F, what is the range of the height the Ewoks travel? So keyword here, range, which is talking about our y-axis, which is talking about meters. It also references heights right here. So this is asking you, what is the lowest height and what is the highest height? So thinking about our graph, the lowest the graph ever goes is 0. The highest the graph ever goes is going to be the y value of your vertex, which we got in part D, is going to be 16. We're going to use square brackets for both of those because both of those values are included in the range. Part G says, over what time interval is the Ewok above 7 meters? So I'm going to, looking at our graph, since I just sketched it over here, it's really hard to tell. So I'm going to go back to the table. Above 7 meters, well, it's at 7 meters at 7 seconds, and it's at 7 meters at 1 second. So between 1 and 7 seconds, it is above 7 meters. Now this time, I'm going to write that as an interval, but I'm not going to use square brackets because at 1 second, it is not above 7 meters, and at 7 seconds, it is not above 7 meters. So between 1 and 7 seconds. And then part H, what is the height of the Ewok at 1 second? Will it ever be at that height again? So at 1 second, I'm going to do this work in blue over here because I'm out of space down there. That's really just asking us plug in 1. So this is saying let t equal 1. When t equals 1, what do we get? Well, I'm going to cheat because we already did this work on the other page. When t equals 1, the height is 7 seconds. If we hadn't already done this work to graph, then you would just plug in 1, negative 1 squared plus 8 times 1. When is it at this time again? Again, we can look back at our table. It's at 7 meters again at 7 seconds. Oops, this should say meters at 7 seconds. It's also at 7 meters. So the thing that I love about this question is it really used almost every single part of the graph. It used the y-intercept, it used the axis of symmetry, it used the y value, the max or min value, in this case, the maximum value. It talked about how long it's in the air, which is basically asking you from x-intercept to x-intercept, how long or how much space does that take up. It asked us about the range. It's asking us to look at the graph and analyze when the graph physically goes above 7. and it asks us for a specific height at a given time. This is extreme. This is a whole lot in one question. You're typically not going to see this much information in one question, but I wanted you to see how all of this information, we really pretty much found all of it on this page over here when we were just graphing it. Once we got to this question looking at the different pieces, we were really just analyzing and looking for what is this question specifically asking me about. So we're going to do one more example. I'm going to flip to this next screen. It would be a great time for you to pause this video and see if you can work through some of this without me. Maybe just start with part A. If you don't have time to do that and you want to just keep chugging along, I think that's great, but it is good to practice and then see how you're doing. Okay, question 2. The Rebel Alliance is celebrating its latest victory by launching a rocket carrying fireworks from a hill 80 feet above the lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by this function, where t is in seconds. So right now, let's go through and identify the important information. First of all, I'm definitely going to need this function. I'm going to want to know that t is in seconds. I want to make sure I know that this is in feet. So part A says draw a picture. I'm going to try and draw a small picture so I save some room to do work. I have a rocket. So notice there is a negative sign in front of this parabola. So I have some sort of parabola that is opening down. At the top, at the vertex, it's going to explode and set fireworks off. And then the rocket is going to drop down even though the fireworks sort of left and exploded. It says that it's being shot off from a height of 80 feet. So what that actually is telling me is that the y-intercept right here is 0, 80. So I'm going to label my axes. This is time, and it's in seconds. My height is my y-axis, and that's in feet. So let's look at part B. This is all I'm asking for when we're saying draw a picture. Get an idea of what's happening. The parabola is opening down. It has a y-intercept of 80, meaning it's starting at 80 feet. So now moving on to question B. What is the height of the rocket at 1.5 seconds? So I'm going to do part B in purple, but I'm going to just go down here. I know I'm going to run out of space. So it's asking for the height, which is the y value, at a specific time. That's giving us our t value. So what we're doing is we're going to plug 1.5 in for t in all the places where there is a t. Negative 16 times, and I hate 1.5. I'm going to write it as 3 over 2. Oh no, running out of space. Negative 16 times 3 over 2 squared plus 64 times 3 over 2 plus 80. And I'm going to simplify this. Negative 16. Remember that when you square a fraction, you square the numerator and the denominator. That's going to give me 9 over 4. 64 over 2. So I can simplify this. Half of 64 is 32. 32 times 3 is going to be 96. So plus 96 plus 80. Negative 16 divided by 4 is negative 4. Negative 4 times 9 is 36. So negative 36 plus 96 plus 80. That's going to give me 140. And we are talking about height. So the answer to this question is 140 feet, according to this problem. At 1.5 seconds, or at time equals 3 over 2, the height of the rocket is 140 feet. Part C, when will the rocket be at this height again? So the thing I want you to think about here is that our parabola is symmetric. It's symmetric over the axis of symmetry, which we don't actually know what that axis of symmetry is yet. But if we can figure out what that axis of symmetry is, we can figure out when it is at that height again. So I'm going to bring part C down here. So the very first thing I'm going to do is I'm going to find the axis of symmetry. In this case, that's going to be t equals the opposite of b, which is negative 64 over 2a, which is going to be 2 times negative, not 32, 2 times negative 16. This is going to give me negative 64 over negative 32, which is going to be 2. So at 2 seconds, the rocket is at its maximum height. So thinking about this, we know that at 1.5, it's at the height we're talking about. We want to know when it's at that height again. So how far away is 1.5 from that axis of symmetry? It's 1/2 away, which means it will be at that height again 1/2 of a second later, which means if I was at 2, this is going to be at 2.5 seconds. And all we did to figure that out was use symmetry. It was 1/2 below the axis of symmetry. It will be at that height again 1/2 after the axis of symmetry time. And then last but not least, what is the maximum height of the rocket? Well, we just did the work to find the axis of symmetry. So this will happen when t is equal to 2. So we need to figure out what the height is, or what the value of the function is when t is equal to 2. So negative 16 times 2 squared plus 64 times 2 plus 80. That's going to be negative 16 times 4 plus 128 plus 80, which I'm running out of space. Negative 64 plus 128 plus 80, which is 144 feet. So that's going to be the answer to part D. I know this video was really long. I'm sorry about that. You should take your time, go back, rewatch different pieces. We're going to be making a lot of videos about word problems because we know they're really difficult to understand. But draw that picture, analyze what each part is, label those axes, stick to those tips on the first page of these notes.